distance walking optimizations. So you can use optimizations for more than just finding the biggest area when you have a given perimeter or the best perimeter when you have a given area. So distance walking. Here you're in a boat and you're 4 miles from shore and 10 miles from home. All right, so if you can row the boat at 3 miles per hour and walk at 6 miles per hour, where should you row the boat to shore so that it takes the least amount of time to get home? All right, well, first thing we need to figure out is, how far we're going to have to row to home. Okay, so to set this up, well, we know we're 4 miles from home, 4 miles from shore, 10 miles from home. All right, so if we call this distance x, we know this is 10 minus x. And we know this is 16. The square root is 16 plus x squared. How did we know that? Our good friend Pythagoras. X squared plus b squared equals c squared. So 4 squared plus x squared equals c squared. So 16 plus x squared equals c squared. So c is the square root of 16 plus x squared. All right. Now we got to figure out our time by boat. That doesn't look like boat, but that's boat. All right, so we know distance is d equals r times t. All right, so we know our distance by boat is going to have to be 16 plus x squared. And that equals the rate, we can row the boat at 3 miles per hour, times t. So t equals the square root of 16 plus x squared over 3. All right, so once we find x, this will tell us how long it's going to take us to row by boat. Now what about time on the ground? Okay, so once we get to shore, we're going to be on the ground. All right, so it's supposed to say ground. Anyway, time on the ground, well, it's still going to be distance equals r times time. But our distance now is going to be 10 minus x, and that's going to equal 6t. So our time on the ground is going to equal 10 minus x divided by 6. All right. Now, for our overall time, what we're going to have to do is add these two together. All right, we're going to have to add them both together. So our total time is going to be the square root of 16 plus x squared over 3 plus 10 minus x over 6. All right. Now, for the sake of time in this video, what I'm going to have you do for a ticket in the door is I'm going to make you find t and x. But I am going to be nice to you. All right. I'm going to go ahead and give you t. It's going to take you 2.821 hours. And I'm going to give you x. Now you might say, I wanted you to find them. Well, I do. I'm giving you the answer so you know if you found it correctly. Okay. Think about it. How do you find an optimization? Well, if you remember back from last time, you had to find the derivative. Okay. And you'd be correct. So you're going to have to find the derivative of our overall time equation. T equals the square root of 16 plus x squared divided by 3 plus 10 minus x over 6. You're going to need to find the derivative of this equation. Once you find the derivative of this equation, now what would be your next step? Hopefully you said you're going to set it equal to 0 and solve for x, because that's exactly what you're going to do. You're going to set it equal to 0, solve for x. When you get x, x is going to be 2.309. And of course, to find t, you're just going to throw x in and find t as 2.821 hours. So it's going to take you a little under 3 hours to get home. What I want you to do now, okay, because I've set up the problem and I've given you the answer. What I want to see on your paper when you come into class tomorrow is I want to see that you took the derivative of the overall time equation and found the value of x on your own. All right. I am going to warn you. It's not. It is complicated. It's not that easy of a problem. Is it something I think you can handle? Yes. Is it something that anybody can find? No. All right. So I do believe you can do it. I have faith in you that you can do it. I want you to find the derivative of that equation and prove to me that x is 2.309. All right. I'm going to use that as your ticket in the door for tomorrow. So make sure you have it ready when you come to class. All right. See you tomorrow.